Hello students, this is a video for the topic tests. These topic tests have been designed to help you understand your test preparation. So once you've completed the concepts, basic concepts of a topic, pick up these topic tests and attempt them. Once you take the test, go through this video. Here we try to give you a perspective of obviously the solutions and what could have been a good attempt. And if you do like the tests, there are more than 200 such tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make use of these tests. This video specifically is about the topic divisibility rules, and this is test number 3 in the app. Overall, the test was an easy test. Easily 7+ questions could be attempted, net correct, and the attempt time would be somewhere around 20 odd minutes. If we have look at the questions one by one, the first question says, how many odd positive 3-digit integers? 1, 2, 3. Odd means they have to end in 1, 3, 5, 7, 9. Are divisible by 3 but do not contain the digit 3. Okay. So since they are odd, the last digit could be 1, 5, 7, or 9. For the last digit, there are 4 options. For the first digit, we could have any number from 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 3 is not possible. So 3 is not to be used. So for the first digit, we can have 8 options, which will be 1, 2, 4, 5, 6, 7, 8, and 9. Now so 8 options for the first digit, 4 options for the last digit. Now for any combination of digits, for example, if I choose 7 and 5, 7 plus 5 is 12. We have to put in one digit in the center. So we can put either, we cannot put 3. We can put 0, 6, or 9. For these 3 cases, 705, 765, and 795, the numbers will be multiples of 3. So basically what I'm saying is, for any combination, for example, if I take 4 and 1, 4 dash 1, 4 plus 1 is 5. We need one number. To 5, if we add 1, it becomes a multiple of 3. And adding 3 to this number, that is 4. And then adding 3 to this number, that is 5. 4, that is 7. 441 and 471 will also be multiples of 3. So what I'm saying is the first digit can be filled in 8 ways. The last digit can be filled in 4 ways. And for any combination, there will be 3 numbers that can be put in between to get a number divisible by 3. So the total number of ways becomes 96. Counting one by one will take a lot of time, and therefore I'm using a concept of, maybe if we can call it permutation combination as well, directly making case and multiplying. So yeah, if we are counting, the attempt time would go up to 3 odd minutes at least, but otherwise 2.5 minutes, moderate level of difficulty. The base 10 representation of 19 factorial is 1 to 1, 65, 100, 40, m 832, h00. So when this value is calculated and written, this is how this value, where TMH denote digits that are not given. What is the value of TMH? Now clearly 19 factorial has 5, has 15, and has 20 as well. And therefore, when we multiply 2 to these, we can clearly see that there will be 3 zeros in the end. So what I'm trying to say is 19 factorial is not 20 but 10. 1 into 2 into 3 into 4 into 5 and so on into 10 into 11 into 12, 15 and 19. 15, 16, 17, 18, 19. 5 into 2 will give me the 0 in the end here. This 0 will be the 0 here. 15 into even number will give me another 0. So basically 19 factorial has to have 3 zeros in the end. The value of h definitely is a 0. Next, this number has to be divisible by 9 because there is a 9 somewhere here. So if we find the sum of digits, 2, 3, 4, 10, 14, 15, 16, 20, 30, 33 plus t plus m, h is 0. This has to be a multiple of 9. So this could be 36, could be 45. 54 is not possible because t plus m maximum can be 18. So either t plus m is 3 or t plus m is 12. And therefore, one of these has to be the value of t plus m plus h as well, because h is 0. Next, this number also has to be divisible by 11. So we check for 11. For 11, we will say 0 plus h plus 3 plus m. H is 0. So 3 plus m, 4, 7 plus m, 7 plus m, 12 plus m, 18 plus m, 20 plus m. 0, 2, 10, 0, 10, 10, 11, 11 plus t, 12 plus t, 13 plus t. So 20 plus m minus 13 plus t, which is 7 plus m minus t. Now this should be either 0 or 11. It cannot be 22. If this is 0, in that case, m minus t is equal to minus 7, or t minus m is equal to 7. Therefore, we get four equations as t plus m is equal to 3, or t plus m is equal to 3, or t plus m is equal to 12, combined with t minus m is equal to 7. This also combined with t minus m is equal to 7. If we solve this, we'll get t is equal to 5. Adding 2t is 10, so t is 5, and therefore m is equal to 2. M is equal to minus 2 we will get, which is not possible because m has to be an even number, so this is not the case. Here we will get 2t is equal to 19. T will come out to 9.5, so not possible. So this case is not true, and therefore 7 plus m minus t is equal to 11, which means m minus t is equal to 4. We combine them with the two equations. T plus m is equal to 3, m minus t is equal to 4 or 12. T plus m is equal to 12 and m minus t is equal to 4. If we add this, we'll get 2m is equal to 16, which means m is equal to 8. If m is 8, t will be 4. This could be one solution. Here, okay, we will solving for 3 and 4. I made a mistake here, just a second. The two sets of equation will be t plus m is equal to 3, m minus t is equal to 4, which will give us 2m as 7, which is not possible. M cannot be decimal value. From here, we will get 2m is equal to 16, which means m is equal to 8. And if m is equal to 8, t is equal to 4. Therefore, the values of t plus m plus h will be 4 plus 8 plus 0, which is 12. Again, overall, the level of question is not very difficult. We are just checking for divisibility by 10, 9, and 11. But again, there are two cases that are formed in for both the four divisibilities 9 and 11. So the question might take some time, and therefore moderate, about 2.5 minutes to solve. How many positive 3-digit integers are palindromes? Palindromes means if we reverse the order of the digits, the value will remain the same in multiples of 11, 3-digit. If the first number is 1, the last number has to be 1. The first and last numbers will be same. If it has to be a multiple of 11, 1 plus 1 minus this number should be 0. Difference of sum of alternate digits from the units in the tens place should be 0. So here we will have to have a 2. 1 plus 1 minus 2 is 0. That is the only case with 1. If we have 2 and 2, 2 plus 2 minus 4 is 0. 3 plus 3 minus 6 is 0. 4 plus 4 minus 8 is 0. 5 plus 5, 10. Cannot put 10, so no case here. 6 plus 6, 12. Cannot put 12, but I can put 1. 12 minus 1 is 11, multiple of 11. 7, 7, 14, minus 3 is 11. 8, 8, 16, minus 5 is 11. 9, 9, 18, minus 7 is 11. So 1, 2, 3, 4, this is not a case. 5, 6, 7, 8 such cases are possible, and that becomes my answer. Again, easy question. Even counting should not take too much time. a question that should be, we should be able to do in about 1.5 odd minutes. A 6-digit number 357 ABC has 6 distinct digits and is divisible by each of 3, 5, and 7. 357 ABC. Distinct digits. This is divisible by 5. And therefore, the last digit has to be 5 or 7. 5 has already been used, so cannot be used again. This has to be 0. 5 or 0 divisible by 5. So this has been tested for. What is the smallest possible value of a plus b plus c? Smallest possible value of a plus b plus c. Now clearly a cannot be 0 because distinct digits. So we'll have to take the value of a as say 1 and check. Or better still, since you want the minimum possible sum of a, b, c, the minimum possible sum will be when the values are 0, 1, 2. So if we arrange these numbers in such a way that one value is 0, one is 1 and 1 is 2, we'll be able to get the answer. 0 already has a place. 0 plus 1 plus 2 is 3. And if you look at 3, 5, 7, 3 plus 5, 8 plus 7, 15. This is divisible by 3. And 357, 7 5s are 35, is also divisible by 7. So we are just looking for ABC to be divisible by 3 and 7. So if I put A as 2 and B as 1, 210 is divisible by 3, 2 plus 1 plus 0, and 210 is divisible by 7 as well. 7 into 30, therefore the minimum value of A plus B plus C will be when A is 2, B is 1, C is 0, which is 3. Again, I think an overall easy question. To minimize the sum, look at the minimum values and just distribute them. Not more than a minute and a half to solve this question. What is the least positive integer n for which 165 into 513 plus 10n is a multiple of 9? So let us look at the remainder that the first part leaves when divided by 9. 6 plus 5, 11 plus 1, 12. 5 plus 3, 8, 1 plus 9. So if I look at 165 plus into 513, 513 is divisible by 9 and therefore this entire thing is divisible by 9. So if I want the entire term to be divisible by 9, we need 10n to be divisible by 9. What is the least positive integer? So 10n will be divisible by 9 when n is equal to 9 and 10n is 90. So the value of n becomes least positive integer becomes 9. Again, I think easy question because 513 is divisible by 9. From there, we're just putting the value for n. What is the smallest positive integer consisting solely of ones, which is divisible by 3? If a number is divisible by 3, the sum has to be a multiple of 3. If we are writing ones, if we write 3 ones, the sum is 1 plus 1 plus 1, which is 3, hence divisible by 3. So the smallest number becomes 1, 1, 1, and that is the answer. Barely something that can be called a question. Definitely within a minute and move on. A is even and both root of A and cube root of A are integers. If A is even, it has to be a multiple of 2. Also, since square root of A can be found and it is an integer, so A has to be a square and A has to be a cube as well. If we say that the power of 2 in A is n, we can say A is equal to 2 raised to power n into whatever, 3 raised to power m into 5 raised to power whatever it is. So some other part. 2 raised to power n into some other part. Let that be b. Now, since root a is an integer, root a will be 2 raised to power n by 2 into b raised to power 1 by 2. This also has to be an integer. So n has to be a multiple of 2. Cube root of a will be 2 raised to power n by 3 into b raised to power 1 by 3. Again, this is an integer. So the power n has to be a multiple of 3 as well. What is the largest integer which must divide a? Now, the first number, which is a multiple of both 2 and 3, n is equal to 6. So a will definitely have 2 to the power 6. No matter how we try to write it, there could be numbers which are higher. For example, a could be 2 raised to power 12 into 3 raised to power 6. A could be 2 raised to power 24 into 3 raised to power 12 into 5 raised to power 24 into 7 raised to power 12, any of these forms, in both cases, root of a and cube root of a will be integers. But what will always happen is it will have a minimum of it will have a minimum of 2 raised to power 6, because that ensures square root can happen, cube root can happen, and a is even. What is the largest integer which must divide a? 2 raised to power 6 definitely has to divide a, and that becomes my answer. So 2 raised to power 6 will be 2, 4, 8, 16, 32, 64. 64 has to divide a for sure. I think moderate level of difficulty, 2 minutes should be enough to figure out what is happening with the question and get the answer. How many positive even two-digit numbers are divisible by 7? If it is an even number, it has to be divisible by 2. We are looking at 7 as well, so we are basically looking at divisibility by 14. Basically, two-digit multiples of 14 is what we want. So the smallest will be 14 ones are 14. The largest will be 14 sevens are 98. By default, all of them will be even. And therefore, total numbers is 1 to 7, which is 7 itself becomes the answer. Again, an easy question within a minute. If it does something like this does show up in the exam. When k is divided by 7, the result has a remainder 3. So we can say k is equal to 7a plus 3. When j is divided by 7, result has a remainder of 4. So j can be written as 7b plus 4. Divided by 7, the remainders are 3 and 4 respectively. What is the remainder in k plus j? So when we find k plus j, that will be 7a plus 7b plus 3 plus 4, which is nothing but 7 times a plus b plus 1, because 3 plus 4 will become 7. If we divide k plus j by 7, we can see this is now a multiple of 7, and therefore the remainder will be 0. When we add numbers, the remainders get added. Because the remainders are 3 and 4, the overall remainder will be 3 plus 4, 7, which now becomes divisible by 7, so remainder 0. Again, basic application of numbers per se. Easy question. Within a minute, you should be able to find the answer. For how many positive integers n less than 9? Positive. So we're looking at n being 1, 2, 3, 4, 5, 6, 7, 8. Less than 9, 9 not included. N factorial plus 1 is divisible by n. Now n factorial is divisible by n for all the numbers. If we add 1, it will not be divisible unless 1 is divisible. So the only number, positive number for which this will happen is 1 factorial plus 1 will be divisible by 1. For all other cases, 2 factorial plus 1 will not be divisible by 2 because 1 is not divisible by 2. 3 factorial 3 factorial plus 1 will not be divisible by 3 because 1 is not divisible by 3, and so on. Hence, there is just one such number. Even if we put one by one values and solve, this will not take too much of time. Easy question. If you're able to spot the fact that n factorial is divisible by n, should not take a minute to solve this question. Even if we are putting values, 2.5 minutes should be sufficient to get the answer for sure. And therefore, if we talk about the overall test, as I said initially, this was easy paper or easy test. 7 plus right net correct attempts is required to get a 90-95 percentile, and the ideal time solving time should be somewhere between 17 to 20 minutes net. The question that I would have done, again, the list is long, but apart from 1, 2, and 7, I probably would have attempted all questions 3, 4, 5, 6, 8, 9, 10. Which are the questions that I would not have attempted? This I thought was a decent level of difficulty question, because if we start making cases, there were a lot of cases, counting would have been difficult. This probably was a good question, or a decent level of difficulty question could have been left. This question, again, if we are not able to get the value of h upfront, many cases get formed. So out of the questions, this probably was on a higher level of difficulty. The rest of them, I think all of these were easy questions, especially because of the numbers given. This seventh question might have created some confusion. So again, the third question that you might take a call on, but I think the rest of them were very, very doable and should have been attempted.